Okay, welcome to today's lesson. Still on cubic functions. Okay, so today's lesson we are going to look at the one which is on the chalkboard. Let me quickly run you through and see how we are going to handle this particular question. Determine the gradient of the tangent to the curve. F of x is equals to 5x squared minus 4x. At the points where A, x is equals to 2, B, x is equals to 5. Okay, so now here, what is it that we are supposed to do for us to find the gradient of this curve when we are given these values as x coordinates? So the gradient, as I said in the first previous lesson, I actually did mention that gradient, that is the dy dx, okay? So that means we need to differentiate this curve. Then thereafter, we are going to substitute the x values that we are given for A and B, okay? So that is the procedure. So let us go to solutions, okay? So what am I trying to say? Remember, f of x, this is simply means y, okay? Whenever you see f of x, it can be any other letter inside there, but that is y. Because when we are dealing with the equations, we are in explicit form, and this is what we are doing. So here we are going to write y. Okay, y is equals to 5x squared minus 4x. Okay, so it is this curve that we are going to differentiate. So how do we differentiate? You have got ideas now because I taught you on how to go about that. So today it is just a direct one. Okay, we are going to multiply this one times the coefficient of this term. Okay, so the coefficient here is 5. So 2 times 5, the answer is going to be 10. Okay, then you write the variable, which is x in this case. Then the power is going to be affected. It's going to be decreased by what? By 1. That means you need to subtract 1 from 2. What are you going to have? It's 1. Do we need to indicate the power 1 there? No. Why? Because that one is invisible. 10x itself is raised to power 1. Okay. Then from there, we go to the next one. Okay. So now when you have a term which is raised to power 1, remember, when you say, let me show it so that you are able to see what usually happens here. So we have 4, because we know that the power there is 1. So 1 times 4, it's 4. Okay? Then we are going to remain with that power, which is 1 there. So 1. Then minus 1. Okay? So that is usually, that is what normally happens. So 10x minus 4. Then this x, we are going to write it. Then 1 minus 1 is 0. Okay? So 10x minus 4, then x power 0 is what? 1. Remember, rules of indices, any number, any letter, anything, be it a symbol, if it is less to 0 is 1. Okay, so this one is going to be 1. So x here now has disappeared because of the power, which is 0. So it is going to be 1. So 1 times 4, it's 4. So no wonder why, when differentiating here, when you have a variable, or when you have a term raised to power, or a term with a variable raised to power 1, we just get the constant, the coefficient of that same term. Okay, this is what normally happens. Having now differentiated, remember, we are given the what? The values of x. So for A now, we come to A. So we are going to say A, we are saying A, x is equals to 2. So we are going to get this differential that you have found. So we are going to say 10. Where there is x, we are going to put 2. Okay, we are going to say 2, then minus 4. Okay, then 10 times 2, the answer is 20, minus 4. So 20 minus 4 is 16. Okay, so for A, the gradient is what? 16 of the same what? Same curve that we have. Then we come to B. B, they are saying x is equals to 5. We get the same answer that we have found. So we get 10, 5 this time around, then minus 4. 10 times 5, the answer is 50, minus 4. So 50 minus 4, the answer is going to be 46. Okay, this is going to be our gradient. Okay, so that is how we answer these simple questions. Thank you so very much. See you in the next lesson.